Hey guys, thanks for joining my video today. Alright, so today I'm going to talk about dBm in more detail and also talk about power and dBm and signal strength and how they're all related, and also the distance related to power, kind of how all that ties together. So first I want to talk about dBm. So dBm, dB, the M stands for milliwatts. So a dBm, 0 dBm is actually not zero power, it's actually 1 milliwatt, because the reference point for dBm is 0 is 1 milliwatt. So 0 is the starting point, if you will. I know I got confused a little bit when I started learning about dBm. It's like, how could it be 0? It's not zero power, it's just the 0 point where 1 milliwatt is. So anything smaller or less than 1 milliwatt would be a negative number. So let's say we have 100 microwatts, or 1/10 of 1 milliwatt, or 10 times smaller, or divide by 10. That would be 10 dB less. That's minus 10 dBm. So that's kind of how that works. Let's start with 1 watt. 1 watt is 30 dB, or 1,000 times more than 1 milliwatt. 30 dB more is 30 dBm. So that's 1 watt. And in my chart, what I did was I put this together as a kind of an idea to just kind of a theoretical kind of an idea where, let's say I am 1 mile away, and me running 1 watt, my signal received at the other end of mile away is S1. That's my reference point. So what happens if I increase the power, or what does it take to increase my signal strength by how much power does it take to get the signal to S2? So that's what the middle of this chart is received signal at 1 mile away. At S1 with 1 watt, it would take 4 watts, 6 dB more, 4 times more power to move the needle up to S2. And to get it to S3, I would need to up the power to 16 watts. And to get to S4, I'd need to run 64 watts. And at 100 watts, it would just be a little over S4. So you look at the difference between 1 watt and 100 watts, which is significantly more, 100 times more power, right? The difference is just over 3 S units. And not to knock on the QRP guys, but they like to brag about how they're running just only 1 watt and they're able to talk so far and do all these amazing things. And it's impressive, I'm not going to discount that, but let's put things in perspective. If I was able to hit a station with 100 watts at S9, I'd still hit the station between S5 and S6 with only 1 watt. So if you look at it that way, it's all not that impressive, is it? You could even go down into the microwatts and still hit this, still receive that, it'd still be readable if your noise floor was low enough. So continuing on with more power, let's say you run 500 watts. Signal would go to S5.5 from an S1 with 1 watt. That's a 4.5 S unit difference. It seems hardly worth it. But let's look at some other things. What if the noise floor is S3? Well, then that 500 watts really becomes worth it, because now I'm 2.5 S units over the noise floor. Where at 1 watt, I'd be 2 S units below the noise floor, and you wouldn't even know I'm there. So you can see power really does make a big difference when it comes to weaker stations, or getting over the signal to noise, the noise, I should say. It really matters, and this is the kind of the question is it worth it? It really does matter when you're on the edge and when the signal's marginal. That's where power really makes a big difference. Where it doesn't make a difference is when the signal's already readable and it's already good and it's already coming in pretty strong because of the way the signals are logarithmic. So let's say you decide to run even more power. You're starting to be a big strapper, big station, right? And you go to 1,000 watts, it goes to S6. You go to 4,000 watts, it's S7. Okay, so to get one more S unit, you got to go from 1,000 watts to 4,000 watts. That's quite a bit change, right? I mean, in effort. And then S8 would require going to 16,000 watts, and S9 would require 64,000 watts. Each time, I'm just multiplying the power by 4, and that results in a 1s unit change. So yes, it's actually true. At 1 mile away, if my signal was S1 at 1 watt, it would take increasing the power to 64,000 watts in order to be an S9 at that same distance. Doesn't seem worth it, right? Well, let's look at it a different way though. Let's look at the chart on the right. Distance, if the signal stays S1, meaning I'm going to now keep the signal at S1. I'm going to say the noise floor is nice and clean and low. And I want to say that I'm just going to have a readable station at S1. It's barely readable, but it's there. Okay. At 1 watt, I'm able to go 1 mile. But if I increase my power to 4 watts, now I can go 2 miles and still have an S1 signal at the receive end. And if I increase my power to 16, I can go 4 miles away. And if I'm running 100 watts, I can go 9 miles. So you can see a 100 watt radio, you can go 9 miles instead of only 1 mile with a 1 watt radio. So, and then if I run an amplifier at 500 watts, I can go 22 miles now instead of just 1 mile with 1 watt. That makes a big difference. And even if I increase the power from 500 watts to 1,000 watts, I can go 32 miles instead of 22 miles. That's a big difference as well. So that starts kind of making it worth it. It seems to matter more when you're right on the edge, down in the mud, if you will. The signal's really weak. And if you continue on in this example, running 8,000 watts, you can go 90 miles. And I grayed out the rest. And I'm sure you could probably guess why. It's because there's this thing that called the earth that gets in the way. So you can run all the power in the world, it won't matter after a certain point. We're talking about 10 or 11 meters. For the most part, it does not follow the curvature of the earth. It would get covered by the curvature of the earth and the signal would be gone. So it may apply to AM broadcasts where it carries, it's such low in frequency, it actually carries a ground wave propagation is more pronounced. So in distance, power really does make a big difference if you're down in the mud and down in the noise floor. Where it doesn't make that much difference is when you're trying to increase your signal strength and trying to impress people with a really, really strong signal. Meaning, okay, let's say a signal was coming in at S7 with 4,000 watts. I mean, to get it past S7, it's almost futile. Meaning, like, to get it to S9, you'd have to run from 4,000 watts to 64,000 watts. I mean, that's not that much difference. You're certainly better off trying to, if you're a base station, try to improve your base station with your antenna. You know, a higher gain antenna would make more of a difference, more bang for your buck at that point. So it gives you, if you think about it, it gives you some encouragement, right? If you're one of those, you listen on the bowl and you hear those big stations, you hear about these guys running over 50,000 watts, and you think, oh man, the difference between their station and mine is so different. I'm only running, let's say, but let's say you're running 1,000 watts. The difference between a 1,000 watt station and a 100,000 watt station is 20 dB. It's 100 times, right? But that's about about 3 S units. Okay, yeah, that's significant. But that would be the difference between, like, say, 60/9 instead of 40/9. Okay, it's significant, but it's not that much. So you could argue that, you know, you still have a fighting chance. A 10,000 watt station and a 50,000, let's say, okay, a 10,000 watt station and a 60,000 watt station is only 1 S unit difference. Imagine that. So a 3CX3000 A7 station is, let's say, comes in at S8, then a 3CX 40,000 whatever crazy, you know, station would only be an S9. There'd be a 1 S unit difference. That's it. That's it. Okay, so of course you get more bang for your buck with a different antenna, right? Better, higher gain antenna. You get more dB out of that. Distance. Okay, so power. A lot of the ham guys say, what do these CB guys don't know what they're doing? They run all this power. It actually can help. Okay, so here's a counter argument to why power really does help. Again, if you're just in the noise and you're getting over the noise, it can make a big difference. And arguably, if you're fighting, you're competing with someone else's station, being 3 dB stronger than them, even a half S unit, is enough to get over them instead of you getting covered up, right? So it kind of does matter there too. But let me use the AM broadcast station example. So there's this station KFI here in Orange County, California that runs 50,000 watts. And if running down to 25,000 watts, there's only a 3 dB difference, then why are they wasting all this power and running 50,000 watts? Why are they bother? Are they just trying to brag? Are they trying to improve S9 to, 20/9 to some? No, they're not. Actually, it turns out when you double your power, it's a 40% improvement in your distance. So that's significant. And that's why they would bother to run 50,000 watts instead of 25,000 watts, because they can get 40% more coverage. So instead of 100 miles, let's just say at 25,000 watts, they would have a 140-mile radius at 50,000 watts. That's significant when they're trying to cover like parts of LA and all the way into, let's say, Las Vegas and all these other areas. I'm not talking about ionospheric propagation. I'm just talking about ground wave propagation here. But anyways, you get my point. Anyway, hopefully this explains some things and clarifies some things. You guys have a good one. Take care.